We are very privileged again to have an overseas speaker. Richö has travelled to Australia just to present at BSides Canberra, so we are very grateful for that. And his talk is on unrubby, reversing bytecode for the lazy. So let's welcome Richö to the stage.
G'day, how's it going? So yeah, my talk is called Unrubby. I'm going to say rubby a lot. It's probably worth getting out of the way up front. Every time I say rubby, I mean Ruby. I've spent a lot of time working on Ruby, and I've kind of lost the ability to take it seriously. And so my internal defense is to call it rubby, and that makes me feel better about the ridiculous behavior that you bump into. The obligatory who am I slide, my name is richö Butts. I speak a lot in the US, and so I have to explain to people how to say my name. Happily, that's this trip has been awesome. I've had literally everyone get it right the first time. I work at Stripe. We're a payments company. I'm obligated to shout them out a little bit. If you want to work with me, come talk to me afterwards. It'll be neat. Me and Mike Ryan have the most ridiculous CVE for a skateboard, as you do. I also run a con, and I jump out of planes and stuff a lot. So this is mostly what I'm doing when I'm not hacking computers and stuff. I'm going to skip the selfie because I'm 10 minutes behind. Maybe I'll take one at the end if we have time. So this talk, it's some cool tricks with bytecode VMs. I want to show you some goofy shit that I found inside of Ruby while I was working on this, because I think it's fun to kick people while they're down, I guess. And I want to talk a little bit about what reversing is, and specifically how you can reverse engineer stuff without actually having to be a reverse engineer. Because while I have friends that think a really good way to spend a weekend is to spend 36 consecutive hours staring at IDA and mashing F5, it's not really my jam. And so I mostly prefer to do a little bit of work up front and then just do a thing and then have source code just pop out the end so I can look at it, because that's way easier. So this talk isn't really dropping Ode or bugs, although it does sort of prove that commercial obfuscation products for Ruby are completely pointless, which I guess qualifies, because I might at least upset a vendor or something. But yeah, that's the TLDR, is I'm just going to show you some cool tricks, and you can maybe apply them to some stuff. So really quickly, some terminology that I'm going to use. When I say VM, I mean a virtual machine in the sense that it's a register machine or a stack machine that's abstracted on hardware. It's not a Linux guest running on your Mac or whatever, which is the other popular term for VM. Opcode and instruction are pretty interchangeable, but they're basically the operations that VM implements. Bytecode is basically just a long string of opcodes or instructions. As I mentioned, Ruby is an interpreted dynamic language. And YAV and MRI are the implementations of these things for the gold standard of Ruby, right? There are a ton of Ruby implementations, but nearly everyone uses YAV and MRI. So how did I get working on this? Fundamentally, there are a ton of companies out there, and I won't name any names, but it's not terribly difficult to figure out what some classic examples of this would be. But for enterprise customers, they want to sell you an on-premise solution so that you can run their software behind your firewall, where you have some control over it, and you can observe it and figure out whether or not it's trying to send all your source code to China. And they want to let you do this, but they want to let you do this in a way that doesn't also give you access to all of their corporate IP, for example, because that's kind of antithetical to their business model. Right? And so the solution people run with is obfuscation, right? You give someone something that's functionally identical to their source code in the sense that when you run it, it does the thing that their software is meant to do. But it's sufficiently mangled that as someone interested in finding bugs or launching a competing business or just doing some recreational corporate espionage, it doesn't have all the useful properties that a full dump of their source code would. Right? And this isn't new. Right? Long before anyone was you know what I'm going to do? I'm going to package up my Ruby SaaS app and sell it for extreme money behind the firewall. Malware authors have been doing this for a really long time. Games developers have been doing this forever with their licensing systems, right? Because it turns out licensing systems that everyone can figure out are not as good as ones that are magic black boxes. And even doing this with bytecode isn't new. Burp Suite, I have a bunch of friends who have been driven to the brink of insanity by trying to reverse engineer Burp Suite. And Burp Suite is still just Java under the hood, right? In theory, you can apply this same technique to it, and hopefully I'm going to nerd snipe at least one person into doing it, because I think it'd be funny. But in a bytecode VM, most of the typical obfuscation techniques are, they're challenging, right? Like with native code, you can abuse performance counters to figure out whether or not someone has tampered with your code. You can use side channels to figure out whether or not you're being instrumented. For example, like the pin framework from Intel is pretty good, but it does like add runtime cost, right? And if you know things about your execution environment, you can figure out whether or not someone's doing things to you, and you can like bail out of execution pretty early. And you can also just like jab at weird instructions and figure out whether or not the emulator that you're in like correctly implements them. It turns out that like Intel Silicon, for example, like doesn't do what the manual says it should in a lot of places, and implementers tend to read the manual and just assume that's correct, right? And so if you like jab at a weird instruction that has a bizarre edge case, you can use that to figure out whether or not the execution environment you're running in is genuine or not. But in a super dynamic language, this is even worse, right? Because you can't mangle a lot of semantic information. For example, if you've ever looked at obfuscated Java, like you dump it into JDGY and it like pops out, you'll notice that all the classes are named class 1, class 2, class 3, and so on, right? Because it's possible for the compiler to take all of the semantic information, like class names and stuff, and throw it away because it can consistently rename everything, right? But in this like super contrived example that I wrote a moment ago in the green room, you can't do that because if you take user-provided input and then you use that to look up a class or a method name and you've renamed the class or method, then like your application breaks horribly. And so no matter what you do, you're still going to be preserving like a ton of semantic information that's really interesting to someone who, for example, wants to reverse engineer stuff. Without a JIT, you also can't do anything super interesting to method bodies. So you can't like obfuscate them too hard because bytecode VMs aren't typically super fast, especially if you're looking at like Python or Ruby or whatever. And without the ability to do anything on the fly, your options are pretty limited, right? And so most of your options are purely in trying to make it very difficult to actually get at the bytecode itself, right? And so like this is a screen cap from some malware I tried to reverse a while ago. Like 1400 basic blocks is a really effective way to tell any reverse engineer to go fuck themselves, right? Like if you want someone to like stop looking, this is a really good place to start. So cool. Before we talk about how to break Ruby, it's worth understanding like how Ruby fits together, right? And so if you wanted to just like evaluate some Ruby code, this is fundamentally what happens. You take a source file, the VM reads it in, and it generates code from it, right? And so this is what that looks like. This is like some goofy Ruby code that I wrote, and Ruby conveniently has this like disassembler thing, which will like take some executable object and spit out the bytecode for it. And like Ruby's bytecode is actually pretty expressive. It's not like the kind of like 6 instruction stack machine that it could be. And so it's not the worst idea to just settle down, like read this and like rewrite the source by hand, but it's like not the best idea. But also it has a pretty printer that will actually render it as an AST, right? So you get like nesting, you get some understanding of how objects and calls relate to one another, and like you get another layer of semantic information. So this is like the first example of something super goofy and hilarious that I found inside of Ruby while I was working on this. So this is inside the Ruby compiler, they have their definition for their bytecode format. And I really enjoy the idea that they have like a major version and a minor version, and above that a comment being like, oh no, compatibility, as though like they have version numbers. How do you run into compatibility issues when you know what version stuff is? So anyway, once you have this code gen, like once you've taken the source code and turned it into bytecode, you evaluate it, right? And that's like fundamentally how this all works. If you're planning on obfuscating your code, you just have to add a couple of extra steps, right? After code gen, you do obfuscation, you emit that into some obfuscated source file, and that's what you ship to customers. And then at runtime, you unpack that back into some format that's like somewhat executable, and you evaluate that, right? And this is what it looks like. This is a super contrived example of like what this might look like. Real world examples look almost identical to this, with the caveat that I was trying to avoid trying to put things that might be watermarked into my talk, because I thought that might come back to bite me. So Ruby is super dynamic. Runtime debugging is like very well supported. And so as like the dumbest possible starting point, you can just like add instrumentation at runtime, right? You can attach a debugger to the process and call rbf eval a lot, which lets you evaluate statements in the current context, right? And so you can like explore what's currently loaded inside the VM. There's also a really cool debugger called pry, which if any of you have done Ruby things before, you might have interacted with. It's pretty sweet. It just drops you into a REPL in context, and you can like type in Ruby code and explore your environment, right? And you can get like reasonably far with that. But again, like if you're interested in, let's say finding a bug in like a 10 million line code base, like you're not going to do that by like typing where am I into pry a lot, right? It's just simply never going to work. It's also like really plausible to break these things. Like pry is really, really easy to disable at runtime, or at least like easy to disable in ways that are annoying and difficult to re-enable, as well as like you can turn off RBF eval like fairly straightforward if you're like bundling a VM, for example. So all of the dynamism that you can abuse as an attacker is also like sometimes really handy as a defender, right? Because you can figure out some things that people are trying to do. But Ruby is open source, and you can modify it, and it's not a black box binary like, for example, Oracle's JRE. And so you can just slam your own debug interfaces in. So I did all of this work on the reference implementation, which is MRI I mentioned before. Pretty much everything targets it anyway. I guess like the exotic Ruby interpreters aren't super widely used, at least as far as I can tell. Ruby and Python both had this like fascination with trying to build like, I guess, an off-market interpreter that went really fast. But as far as I can tell, like none of those attempts were really successful. But happily, most of these products that like commercially obfuscate things also ship like a ton of loaders. And so in actuality, the version that they want to run against isn't necessarily the one that you have to use anyway. Like typically, if, for example, you only had unrubby targeting one version of Ruby, which is what it does, you can actually just like backport the vendor software to use this instead, and everything will just work, which is pretty cool. So anyway, like we're now at the point where it's like, well, I'm interested in having a look at the insides of some software. I have like the Ruby source, like where do I go from this? And so RB eval iseq is like the most interesting thing. So we have these things called instruction sequences, which are basically like strings of bytecode. And Ruby has this function called RB eval iseq, which like takes one and evaluates it. And this is the patch that I added to Ruby to like get all of this working. It's really, really straightforward. All it did in this instance is every time you try and evaluate an instruction sequence, it calls disassemble on it, and then it prints it to standard out, right? And like the immediate result of this is that your terminal explodes and catches fire. But in like the smoldering wreckage of that, you have the entirety of the instruction sequences for like the entirety of the Ruby program that you fed in. And so, for example, if this is like a commercial product with like 10 million lines of Ruby, it's a lot. And again, like it's kind of back to that like 1400 1400 basic block function. Like you're not going to rummage through that by hand. But to first order, this proved that like with a single patch to Ruby, I could defeat like all obfuscation forever. Because this works without any knowledge of how their loader works, right? Like their loader does its thing, and then afterwards it calls into the VM, and I'm like, oh, cool, instruction sequences. Like I love looking at those. And so no matter what they've done to like mangle or unmangle them, I still get to look at them in the end, which was pretty cool. And so at this point, I was like trying to figure out what I could do to take like this, well, now I have access to the instruction sequences, but that's not really what I wanted all along, and do something more interesting with it. So I started digging around for like other symbols that might be interesting. So RB eval iseq like evaluates instruction sequences, but there's also like RB defined method and VM defined method, which is called every time you create a new method in the VM, right? Which is like realistically more interesting to you. Like evaluating stuff isn't that cool, but like explaining the structure of the code base and like defining methods is suddenly really interesting. There's also RBF eval, which like I did pull apart a bunch of software in the process of this research, right? Like, you know, for academic purposes or whatever. And the vast majority of things like call into internal like Ruby data structures and like define methods and like do something at least like somewhat insidious and annoying to reverse. But I did bump into one that like the entirety of their obfuscation engine had like, it's a little more complicated than this, but semantically what they did was rot13 the entirety of their code base, like comments and all. And then like unpack it in memory and then just like call eval on it, which was pretty cool because like in general you never expect to get the comments back. So I was like really pleased by that. But like that's not, I guess like you shouldn't bet on that happening every single time. All right, so we have bytecode, but like what do we do with that? Like how do I get further than like reading bytecode and trying to figure out what I could do with it? So Ruby's VM is a stack machine. It basically has an instruction pointer and like a flag register with a bunch of like conditional jumpy stuff in it. But in general, everything resides on the stack, right? So all operations consume their operands from the stack and leave them behind. And so as you dig through, you'll see like an increasing number of like put object calls, for example. Like this code is like fetching a constant, which leaves it on the stack, interacts with the cache, which we can like happily ignore. it puts another object on the cache, and then it sends a send message, which basically says invoke a method on the object on the stack using the other object on the stack as an argument, and then it retrieves the object from the stack and sets it to an instance variable, right? And this is like fundamentally how everything works. Right, and this is pretty cool because when we're looking at the bytecode, we can basically just model the stack in memory and like figure out what it would have done. And this provides like a pretty straightforward path to translating everything back into like equivalent source code. It's also kind of cool because you can check your work, right? You take your bytecode and you try and reverse engineer, like you try and translate it into source code, and then you compile the source code, and if it comes out the same as the bytecode, then like great, you did it right. So you have this like really easy like ability to check your work as you're going, which means that you don't do, for example, months of work and then discover that some of your core assumptions are wrong and realize that you screwed up your life, which I've done a bunch of times. So like I said, the IR is like pretty easy to read. I did actually find some bugs by reading it by hand, but like because it's so expressive, decompilation is super tenable. So I started writing a decompiler because that seemed like a fairly obvious step at this point. And the bytecode is really expressive, so it wasn't super challenging, but like a few hours in, I was like, this is really, really annoying. I don't want to do this. I wonder if anyone else has done this. And it turns out this guy, Michael Edgar at Dartmouth, wrote this thing called reversal, and you just give it instruction sequences, and it turns them back into source code. I was like, oh man, this is really convenient. This is the exact thing that I wanted. Reversal operated on like some really old versions of Ruby, and it had some like sort of clown shoes bugs in it. Amusingly, the Ruby that it was set up to work with, like, literally didn't even build, even when I checked out, like, that specific revision from GitHub, which I'm probably never going to understand. I think this is, like, what interacting with academia is like, but I'm not really positive. But this project was also last touched in 2010, which, like, I think I started this in 2006-ish. And so, like, there was a big gap, and it's, like, understandable that bit rot kind of occurred. I kind of touched on that, like, the VM has grown more instructions. This is one of my favorite, like, goofy things in Ruby. So the VM has, like, a ton of joke instructions in it, which is, like, fine, you know, whatever. Like, you might as well add jokes. The thing that pisses me off about this is that the optimizer doesn't know anything about this instruction. Like, it just seems counterintuitive to me. Like, if you're gonna add a goofy instruction that puts the string a bit of bacon, lettuce, and tomato on the stack, you should also teach your optimizer to find references to the string literal, a bit of bacon, lettuce, and tomato, and use this instruction, because it'd be way cooler, and it probably would have foiled my reverse engineering efforts. There's also this gem, which my terminal can't render the help for. But if you invoke the answer instruction, you get 42, which makes sense, I guess. But so while I was doing this, the reason I found these two instructions is because I was trying to write a decompiler, and I was trying to add support for instructions that weren't supported. And that was like, well, I kind of needed to know what instructions did. And so I was digging through, there's a file called instructions.def, and it is like this goofy C macro thing that like defines all the instructions in the VM, right? And so every time I bumped into an instruction that I didn't know how it worked, I was like, oh, sick, this has documentation. It's going to be awesome. So Ruby is now in English language, like officially the Ruby community operates in English, but this is like not really true for a lot of the code base. So I was looking at expand array, and the English help says expand array to num objects. And I know enough about information theory to know that like Japanese is like character for character, like meaning dense compared to English. And that's also just a lot more characters. And so I'm willing to bet that there's like some interesting stuff that expand array does that doesn't fit neatly into the description expand array to num objects. So I got really tight with my friend Zizak, who is like learning Japanese and super excited about Ruby. And so like we spent a good long time like trying to decode a lot of these help messages because we were like super interested in what on earth is going on here. And especially like there's like enough English identifiers in there, like the repeated references to nil are definitely some like kooky edge case behavior. But to be fair, the flip side of this is because I had the ability to kind of check my work by recompiling my decompilation artifacts, when I couldn't figure stuff out, I did have like a reasonable attempt because I'd just like try something and then like see how it differed from the gold standard. And like by and large, it was pretty tenable. It also turns out that like of the emitted code, like probably 78% of it is like effectively no-ops. Like MRI emits a ton of instructions that relate to the cache, and it turns out when you're decompiling stuff, you can just like throw all of them away, and everything still works. So I started trying to revive reversal. I was like, this project looks pretty cool. I think I'm going to use it. So the first thing I did was I just like did the like edit make loop until it built cleanly. And then I realized that it was targeting like a comically old Ruby that like even the loaders that target everything were like, haha, that's really old. We don't want anything to do with that. So I added support for 193, which like for a long time was like the gold standard Ruby. Amusingly, like they released 194 and then we're like, that's a bad plan, don't do that. So I got it up to 193 and then I subsequently got it up to 2.1, which is now a few versions behind, but it's like super modern enough. Added support for a bunch of new instructions, including some jokes, because I thought it would be pretty cool if it could, if Reversal at least kind of knew about them. And then I bundled it all up and shipped it. So that's unrubby. So unrubby is basically like a suite of things. It gives you a Ruby VM, so you can run software with it. It hooks a ton of internal behavior for reasons I'll get into in a second. It reaches out to Reversal for decompilation, so like basically you just hand it like something that invokes Ruby code, hopefully eventually, and it'll just like turn it back into source code. And then it prints it out for you so you can, you know, mess with it, do what you want. So like, why not just use Reversal on its own? Like, why did I do all this like futzing around with a Ruby VM? The biggest reason is because Reversal is pretty cool, but it's also pretty fragile. It gets confused reasonably easily. It's definitely not perfect. And its underlying assumption was that it could just give it a whole program and it'd like figure it out, and ultimately it just kind of wasn't smart enough to pull that stunt off. But by hooking the behavior of the VM, suddenly I'm populating a lot of internal state. Like structurally, unrubby without Reversal can tell you about all the classes and methods in the program, which like for some use cases is actually more than enough information to reverse everything anyway. And ultimately, because it's so deeply tied to the VM, it's actually really, like, I've spent a lot of time trying to figure out, like, if I worked for one of these companies that obfuscates Ruby for a living, like, how I would stop people like me from doing this, and I still haven't really come up with anything, because you sort of tied to all this, like, structural fragility of, like, having used Ruby in the first place. So like I mentioned, it does claim it can turn a whole program back into source, and it has some really contrived test cases in the code base that do this, where you hand it like a 7 million line instruction sequence and it turns it back into the whole thing, because like defining a class is still just invoking an opcode as far as Ruby is concerned. But in practice, I found that it nearly always gets really confused and it like loses, like it doesn't keep track of like scope, and so actually all of your classes in the entire 10 million line code base are like infinitely nested, which was a really fun bug when I first bumped into it, because like it tries to indent everything nicely. And so incremental compilation, where you basically like tease apart the structure of the program and then you hand it basically just method bodies and just like class bodies and ask it to decompile them, works way better. This is A, because there's like less internal state for it to get lost in, and B, because when it gets everything wrong, you get to like start with a fresh context on every method. So if you eyeball a method and you're like, that's wrong, that doesn't make any sense, there's a good chance that the thing next to it might still be correct, which was very much not the case when you hand it like the whole program as one giant instruction sequence. So there are like a few levels to this. Like the other thing that people do is like generate deliberately difficult to read bytecode. And like, I guess a really, really trivial example of this is like creating a class, right? So like creating a class in Java, for example, like you can do it dynamically, but you can also like basically specify it inside of a class file. In Ruby, there is like only one way, he says, about to show you the other way. But so there's this opcode called define class, which like takes some arguments and it like creates a class in the current namespace. But you can also load the constant class onto the stack, and then you invoke the new method on it, and like eventually this will kind of like run through enough Ruby machinery to generate a class. But it does so through like two almost entirely disparate code paths. And this was one of the things that Reversal struggled with at first, because its internal notion was that the only way to define classes is via the define class opcode, and so its decompiler would like hone in on that as the only way to do it. And so I was like, nah, not to worry, I can fix this. So I started hooking more and more stuff inside of the VM. And so by hooking RB define class, it doesn't matter whether you define a class with define class, whether you like call class.new, whether you like eval the string class.new, like it doesn't matter what kind of goofy piece of plumbing you use to like wind up at a class definition. The instruction pointer always finds its way into RB define class, and I always get to include that in my class map. Right? And so this was like the important part, which was like removing all of the like structural fragility that you have to deal with by virtue of like being in Ruby. So I started adding a bunch of patches, and they were all like really, really simple. This was like the first and most important one, which was that there was this like really hilarious loop where if you included reversal from user space, it would start trying to decompile itself, and then like everything went sideways pretty quickly after that, so I stopped doing that. I started adding these like really tiny declarations to basically every method that like builds up internal state. Like anything that defines a constant or attaches a method to a constant inside of the VM, I just added these little stubs to it, which basically like decompiles it and then shoves it into this like huge class map. And that class map is just a native Ruby object. And so if you decide that you want to work on this, like you're not stuck with just like handing it off to reversal and doing whatever. Like you can pop a REPL and then start fiddling around with the class map and like look at it and like write your own static analysis pass or whatever. You can do all kinds of fun stuff, which it turns out was my next slide. I'm getting ahead of myself. Doing great. But so this is basically what that winds up looking like. There's a hash of hashes, and each one of them includes like the methods, includes, extends, and whether or not it has a superclass. I did run into a really fun bug yesterday when I was rewriting all my demos because I accidentally deleted them. That like this approach actually loses some ordering information, which turns out to be semantically relevant, and so this is like the next bug that I'm going to fix. But currently it doesn't understand whether like at what point you included another method, included another object, which it turns out like drastically alters program behavior. But it also has a couple of other like I guess unexpected benefits. One of which is that if you have lots and lots of goofy metaprogramming, because of the way the Ruby VM works, it will actually effectively unroll it for you. This may or may not be a bonus. If, for example, your metaprogramming exists because you needed to define 10 million methods that are nearly all the same, you may not regard it as like a huge favor that I did you by like giving you the concrete implementations of those 10 million methods. But for the most part, it actually works out pretty well. A good example of this is if you've ever used Sinatra. Sinatra has like a magic get and post like class method on its controller class, and you invoke that, and it like under the hood defines a method to actually handle it. Because of the way this works, it will actually give you the concrete handler classes and not just those like get and put declarations, which turn out to mostly be more useful, especially if you're trying to do like a static analysis kind of thing. So yeah, we get all kinds of stuff. It's kind of a nightmare inside of Rails because Rails is full of magic. But for the most part, I think this is like pretty neat. So RB-defined class, I kind of lied to you before. RB-defined class is like absolutely not the only way to define a class. It turns out this is like fairly unique. Like it's only because like classes are one of the two universal primitives. Like everything is either a module or a class at some point in the Ruby hierarchy. And it turns out like hooking RB-defined class didn't get me far enough. So I just like added my hook function to literally everything in class.c, and that like pretty much made the problem go away. All right, so I do have a demo. You're gonna have to bear with me for a second because while I was trying to make this dongle work, I restarted my computer, and so my like carefully laid out demo is not anymore. But I bet I can do this. Live demos always go so well. All right, so this should be over here, and then I don't remember how to full screen things on my new laptop. And if I embiggen this somewhat, can you see that? Okay. Sweet. So I have this. It's not like I started really late. This will be fine. I've got heaps of time. Ah, sweet. Okay, so I have this VM here, and I have a copy of unrubby, and then I have in demo. So I downloaded a commercial application, which I'm praying doesn't put its watermark near the end, and I used it to encode the CSV library from Ruby itself because I was like, well, at least like the thing I'm encoding isn't commercial, so that's good. So anyway, this is like basically what it spits out. It does like a little bit of magic to try and find its loader, and then it hands a base64 encoded string off to its loader, and it's like, hey, load this in. And so if everything goes really, really well, which it won't because Control-R doesn't work. Oh god, how does this? Yeah, that looks about right. Okay, so what I'm doing here is I'm deferring reversal because it tries to load it itself, but I found a ridiculous bug in it and I couldn't be bothered fixing it. So I'm telling unrubby not to try and find reversal on its own. I'm immediately telling it where it can find reversal so that it will work. And then I'm invoking, unrubby is just like a drop-in for Ruby, and it will also like evaluate your code. So if you're like, for some reason, trying to figure out like packed malware in Ruby, because I guess that's the thing people maybe do. Like, don't do it on your machine, because it like will actually run the code. But anyway, so I'm going to invoke this, and after loading the CSV library, it's spat out like the contents of the CSV module, which is pretty neat. There should be more. That's weird. Something's gone horribly wrong. I'm going to blame restarting my computer. Anyway, I swear this demo worked yesterday in the green room. If we have time afterwards, I'll dick around, but I would prefer not to waste all of your time while I futz with my goofy Ruby thing. It's all right, you don't have to clap. Failed demos get nothing. So, like, how do we actually like make this like work? The fact that Ruby is like super willing to basically do anything for anyone is like really practical for us, because we can do a lot of goofy stuff to the VM before we jump into like the I guess like attacker controlled code. So we can set up an environment where we're more likely to succeed. So we can preload our library and then like let it jump in, and then we can like hijack execution and like fiddle with more stuff. And this is super useful for the case like where I wanted to not try and disassemble reversal itself, because that like led to some pain. And then we just add an add exit hook. So basically when the VM exits cleanly, we're like, hey, take the entirety of the class map that you generated and just like spit it out to standard out. But so let's say you want to like break something in the real world, right? You have a CSV library that you're curious about how it works, and you can't remember how to get the source out of the Ruby tree. Like, how do you do this in the real world when you have like a real application that you want to look at the source for, but you don't want to accidentally disassemble the entirety of Rails? The naive way to do this is to just implement Rails without any bodies. Nearly all of the applications that I looked at were Rails apps, because that's like what enterprise companies build these days. And so if you basically include enough shims that like all of the calls into Rails like weren't no method error, then you get enough plumbing that it can like define all of its classes and do its thing. But you can also do this like the kind of ridiculous way that's guaranteed to like duck punch your way to glory. So if you're not familiar, method missing and const missing are magic methods that are invoked when you try to access a method or a constant that doesn't exist. And you can also reopen classes and like add more methods to them later, which is like a really bizarre misfeature of Ruby, I guess. So I wrote these two stubs. The first one basically says whenever you call a method on a stub that doesn't exist, just return a new stub that also does that. And on object, I was like, every time you try and access a class that doesn't exist, return a stub, right? And so in actuality, this means that if you try and access anything in the Ruby namespace, you get a stub, and if you try and invoke any method on it, you get a stub that makes everything work, right? And so it's like literally impossible to receive a no method error or no constant error after this. And so if you run any piece of source, no matter what kind of pre-existing state it expects to exist in the universe, it will like run cleanly enough that reversal will get to look at all of its instruction sequences, which is pretty cool, because typically like Ruby applications are split into like not one gigantic file with all the source code in it. They're like organized into a hierarchy that expects to be loaded in a really specific order. And like generally speaking, you don't want to like load the top level thing and then receive like 10 jillion lines of Ruby and like put them into ruby.rb and then like open it in Vim and be like, man, I better know where the bugs are. You want to look through file by file and like figure out like the one called secrets.rb is probably a really good place to start. And so this lets you like decompile file by file instead of being forced to like look at the whole thing at once. So the next thing I kind of thought about was like nearly everything I was reversing like had license servers, and like it's kind of challenging to figure out whether or not like I'm doing something bad and actually stop me, but it's like pretty straightforward to like reach out to your licensing server to be like, hey, here's the checksum of the Ruby evaluator that I'm running with. I don't think it's right. Thoughts? And so I like figured that would probably be bad. And so when I was first working on this, I was like working in an unroutable VM, and that was kind of my isolation primitive to make sure that the things I was tampering with weren't like calling home to be like, hey, you should talk to that richö butts guy. I don't think this is like part of the end user license agreement. But that was super miserable because like I spent a lot of time realizing that I like had forgotten something, and like I'd have to like kill everything and then like make it routable so I could like put stuff into it and then like make it unroutable again, and like I wound up making compromises, and in the end like if people were actually trying to keep an eye on me, then like I failed miserably. So the next thing I did was add this magic environment called unrubby socket hack. All I did was I patched up the entirety of the socket module to like not do anything if this environment variable is set. And so anything that tries to create a native Ruby socket will transparently fail. It will like act as though it created a socket, and all reads and writes to that socket will just like instantly return. But like, this isn't like a perfect defense. Like, again, if you're like doing something insane, like trying to reverse malware or something, like anything that knows how to invoke syscalls or call a shared object can still like reach socket. Like, this isn't a real sandbox. But it is like really cheap insurance against the like, they invoked a Ruby HTTP library to like do stuff. So yeah, I guess like what do you get in the box if you like decide to use unrubby? You get a Ruby source tree, which has been like patched out the arse to have like a bunch of helpers and stuff to make it really easy to do this. You get a patched version of reversal that works with that version of Ruby. You get a Rails shim that's like less invasive than the like ridiculous like duck punch the universe into always succeeding thing, which actually works better because it marks a lot of bugs. And so if you want to play with it, that would be awesome. Like, I highly encourage people to either mess with unrubby or to try and write the same thing, ideally for the JVM, because I think it'd be cool, but like really any bytecode VM you can do this. And there's this like unrubby report bug thing, which if you export it, it's an environment variable, it'll like, if the decompiler chokes, it'll like spit out the instruction sequence that broke it and a little bit of information, and like you can kind of redact it and then ideally send it to me. That'd be sweet. So there's some other stuff in there. Unrubby full iseq is the, I guess, that first prototype I wrote that like dumps instruction sequences out to the terminal. It's like, unless you want to feel like you're compiling Gentoo or something, it's like pretty useless because it just busies up your terminal. But like occasionally it's useful for debugging. Unrubby methods is like the default thing that you want, which just emits a class map complete with populated source. And it's actually been a while. I do know for a fact that exporting YOLO does something, but I don't remember what. But I bet it's good. So yeah, why not? You can also like grep the thing. But you can also toy with the autoloader. Ruby has this like facility. It's really similar to PHP, if any of you have like ruined your life in that specific way, where you can describe a pattern that basically says like, if you bump into a class and you don't know where it is, if you try to access a class and that class does not exist like inside the current class hierarchy, like here is how you should figure out which file to evaluate in order to like do it. And autoloaders are sweet because like a lot of times it's like remote code execution because like you just have to give them a craftily named class. Like if you can coax them into loading an attacker controlled class, they'll just like arbitrarily require files in the file system, which is pretty sweet. Like you're one attacker controlled upload from victory. But you can also abuse the autoloader for fun and profit here in order to like let it explore the program for you and kind of tell you where the fun stuff is. So I touched on this before, that all of the goofy metaprogramming will get expanded in the class dump. I think one of the things I really want to do is like actually gate this behind a switch to like figure out how many, I guess like blocks deep you are when you're defining methods and decide whether or not to do it to avoid that like state explosion of receiving like a 10 million method class dump. So yeah, like how do you actually do this in the real world? It currently targets Ruby 2.1, which is modern-ish, I guess. I don't think the current Ruby, which is like 2.4 these days, has anything backwards incompatible for 2.1. There's just like more modules in the standard library and some performance stuff. Vendors ship shims for their Ruby. One fun thing that you can do is like if you're looking at a bundled program and it only comes with like a single loader for their like the version of Ruby that they intended you to use, you can typically just Google the name of the loader they're using and then go to their thing and then get a demo and then get the shim that works with unrubby because it's the same version and then just like put that by the side of it and all of a sudden it'll all work because everything's super compatible, which is pretty neat. You can also, like, if in the case where some applications, like, obviously Burp is Java, and so this is like a bad simile, but like Burp has like an icon that you double click and it like invokes its own bundled Java, which is like hidden somewhere in there. So like tampering, like you need to open up the package and like stick your malicious Java in there. But you can do the same thing with Ruby programs, right? Like if you open up, I'm really struggling to think of a good example, but there are like tons of desktop applications that are like Ruby under the hood. You can just open up the package file and like drop unrubby in instead, and then like everything will just work, which is pretty cool. So like I said, I spent some time like trying to figure out how I would defeat this. Like if I worked for that company, how would I stop some jerk like me from doing this? And it's a little unclear, right? Like it turns out Ruby is just like a bad language to implement your software in if you want to give it to other people. Like honestly, I think the only real solution is to SGX really, really hard, right? Like you literally put it inside of an execution enclave that like the hypervisor can't look into, but that's kind of extreme and probably more work than anyone's really willing to put into this. You can definitely like, you can play like attack a tag for a while. You can just like introduce more annoying things that you need to bypass. But like, this is not skewed in favor of the defender, right? Like in actuality, it's probably really annoying for you to implement those checks, and it's really not that annoying for me to like make unrubby past them. As well as like any checks that you do inside of Rubby land, like it's pretty easy to smash them as a whole. Like in the same way that I made all class and method resolutions just like transparently work because it was easy for me. Like it's not actually that hard to just like patch all equality comparisons to be like, well, the right-hand side looks like it has a sort of checksum look to it. So yeah, the left-hand side is definitely also the same checksum. Is like something you can reasonably easily do inside of Rubby, which like would break a lot of naive attempts. And so like I think realistically your best bet is to include shadow definitions of like all of the like class and method definition machinery so that you can like twiddle with the internal data structures without ever invoking my hooks. At the same time, like if you did that, I would totally just like hook yours with pin and we'd be right back where we started. And so it really upsets me to say this, and Sam Collinson like wanted to be quoted in my slides but isn't because I forgot. But like I think Node might almost be a good idea, which is horrifying. But purely because you have access to this JIT, suddenly you have like, you're still gonna lose, like you're still coughing up like a lot of the structural information about like how your program fits together, but at least you do have the option to like emit like native code that makes reverses hate themselves for all of your method bodies. You run into this like reverse problem where you need to convince it to JIT literally everything and you need to figure out how to like store the JITted code and hand that off. But like terrifyingly, I think like you should write your enterprise app in Node, I guess. Don't quote me or at me. But cool, the good news is there's like no obvious way to defeat this attack, which is great. And the cost to attack is like really, really low. But you can definitely apply this to other things, which is like the question I typically get asked at the end. So yeah, go and reverse stuff. So like I mentioned, this is like the most important thing. I fixed all the bugs that I bumped into, and I reversed some like pretty substantial pieces of software, which I think means I have like reasonable coverage. But like every time I tried something new, I like consistently bumped into something goofy, right? Like the coverage I have for opcodes is like deliberately driven by opcodes I saw. Like it just looked really annoying to implement all of them, so I didn't when I could get away with not doing that. So please do reach out. Like in actuality, fixing the bugs is really easy. I just need to know where they are. So I wanted to give you a sneak peek of something I'm working on right now. I actually just offloaded this to someone new on my team. But it turns out like porting AFL to Rubby is like not super complicated, especially at the point where you have like this fine-grained information on what the VM is doing. So I wrote a little C shim that like implements the AFL shared memory protocol, and I used tracepoint to basically be like, hey, every time you do something, like reach into this so I can twiddle bits. So it's now possible to fuzz black box Rubby applications and then translate the crashes back into source in like a totally hands-off way that like you don't need to know literally anything about either the way it's packed or written. You just like hand it garbage inputs until something cool happens, and then you like have a look at the source of the bug, which I think is pretty cool. Yeah, so I wanted to shout a few people out. Rich Smith wrote this thing called Pyretic, whatever. He released it at Black Hat like forever ago. It was a fundamentally kind of similar thing for Python. It definitely didn't do a lot of the like ridiculous hands-off, just rename a binary and you're off to the races kind of thing. But he definitely kind of pioneered this idea of extracting like a semantic class map and then populating everything post facto, which I was super grateful for. He also gave a really good talk about it. Michael Edgar for writing reversal, like if he didn't do that, I would have had to write the decompiler, and that would have made me really sad. I'm shouting out the wrong conference on my slides, which is really embarrassing. I fucked up pretty badly. Sorry, Silvio. But really, thanks BSides for having me. I obviously spoke about this at Troopers once. And Dominic, yeah, I just didn't update the slide because it was towards the end and I didn't get around to reading it. So I'm so sorry. Anyway, if you have any questions, I'd love to answer a few of them right now. Or you can ping me on Twitter, or you can email me at work, which is where I've done a substantial amount of the work for this. Cool. Are there any questions?
We might just have time for one question and a selfie for richö as well.
How much program execution do you need to see before you get a useful class map out of Ruby?
Sorry, it was a little hard to hear. Was the question how much program execution do you need to see?
Yes.
So like, the answer is like maybe none, maybe all of it. So the way this fundamentally works is Ruby doesn't have like a separate like compile and run step the way many languages do. And this isn't like novel to Ruby. Python works the same way. But like in actuality, when you run a Ruby program, like all of the class definition, method definition stuff is just it's imperative code, but instead of like immediately having like side effects where it like prints something or does arithmetic, it defines classes inside of the local hierarchy. And unrubby looks at them in real time, right? So like if the program, for example, like defines a bunch of classes and then does a bunch of stuff with those classes and then defines a bunch more classes, I guess like the concrete answer to your question is like in that hypothetical example, if it crashes in that middle part where it interacts with the first set of classes, you won't get to see anything about the second set because they were never defined. But you also like, if you're asking, do you need to exercise the code in those classes in order to get the source of them? The answer is no. As soon as they're defined, like unrubby has looked at them, it's like figured them out, and you will get to look at them. So like the ideal case is that you can load all of the code without ever actually like in the, I guess like web application as a service behind your firewall thing. Like if you can load all the code without starting their web server, it's great because you won't get like debug logs in amongst your source, for example. Does that answer your question? Sweet.
I think there's time for that selfie that you wanted at the beginning if you still want it.
Fuck yeah, there is. Today's a good day. All right, everyone smile, because I'll know if you're not. Rude. All right, thank you all so much for having me.
Let's thank richö for a great talk.